We shall now begin with our panel discussion on theme 2. Panel discussion will be moderated by Professor Santanu Chaudhury, Vice President INAE. The panelists for the panel discussion include Professor Jalil Akhtar, IIT Kanpur, Professor Subir Saha from IIT Delhi, Dr. Bhupesh Lad from IIT Indore, and Dr. Sahu from ICAR IARI. Professor Subir Saha shall be representing our Session 2 Chair, Professor Lakshmidhar Behra, and Professor Bhupesh Lad shall be representing our Session Chair, Dr. N.C. Moon. Over to you.
So after 1.5 years of deliberations, in this section of this technology conclave, where we were looking at cyber-physical systems and different aspects of cyber-physical systems. So we are meeting for the panel discussion with the session chairs with the objective of finalizing the conclusions, because conclusions should also have a kind of recommendations which INAE is expected to take it forward to different agencies, including government agencies, so that the future initiatives in this area, both as a policy as well as a research thrust, can be pursued at appropriate level. So this is the intent of this panel discussion, to really crystallize the outcome and recommendations. So I think with this background, we may have in this form, I would request each of the panelists to give his presentation for about 5 minutes. Then we can come back and try to reach a conclusion. But the tragedy is, the moment I talked about policy, I simply walked out. But the interesting part of it is that these policies decide everything finally. Even the young students, who will they in future and their career, also in many cases will be implied and implicated by the kind of policy outcome that government decides to adopt.
Okay, so very good morning to all of you. So I was chairing a session on IoT and sensors, and in this session we had three talks. I just tried to give a brief idea about the, what's and depending upon the okay. So the first talk was here on there were 3 talks. First was on the RF harvesting, then the 2 were on the sensors. So if I try to briefly say the first talk, basically it was about that how can we use RF sensor networks so that we can energize, for example, IoT devices and sensor nodes. And the idea was that we can go about this in a phased manner. There are challenges. So basically I just give the idea. So RF harvesting means we try to use RF from the ambient. Like, you have RF everywhere. You have the your TV stations, you have the cellular network, you have Wi-Fi router. So RF is there 24/7. And the concept is that if we can use those RF and convert into DC, then we can energize low power sensor nodes. And this is a very new trend. For example, it can augment the solar renewable energy, it can augment the piezoelectric transducers, because and the good part is that as compared to solar energy, RF is everywhere 24/7. So you don't have to go for the weather condition, you don't have to go for the wind. That's one of the advantage, and that can come into what we call technology which is sustainable. So that, because if you imagine that you have all these sensor nodes, even your mobile phone, I would say one step further, and if it can charge on its own without needing any battery, because most of the time if you see all these mobile phones, all these gadgets, their lifetime is limited by the battery. So if you can get away with the battery, lifetime is maybe increased, and that's a very good opportunity, like for a country to go on, that how can we work on the technology to make it popular. Of course, there is a drawback. The drawback is that if you really want to use RF energy from the ambient, if you look at the mobile phone, for example, it is very low energy, minus 70, minus 80 dBm, and that's something where you cannot use it for the practical DC charging. So there we have the advantage that if we can work on efficient system, efficiency means we want to ensure that at very low RF energy can be converted into DC, and that DC should be enough to energize. Of course, it can give you sort of watts or something, but it can give you milliwatts, or microwatts usually. So we have checked in our lab, for example, even that if you have a LED battery, it can be charged using this. If you have just a mobile phone, take its Wi-Fi, and you put your signaling, it will work. So that's something, one aspect where we can work on. Of course, the idea is that you have to optimize. You have to optimize the spacing. You have to optimize. So, for example, Prof. They also work that can you try to make some beamforming network, and can be routing something the way we do for a repeater. That's something where we can work on. So the idea was that we should have a long-term continuity in this, and that will come in the idea of what we call, it can go to the technology which can be sustainable, but we have to customize. You have to customize the technology, you have to customize the RF network, and network here it means the real hardware, because yesterday there was a lot of emphasis on the manufacturing, and this again coming in the sort of manufacturing, because we have to design, develop, fabricate and test the hardware which can work in the real scenario. And that basically means, for example, we have to develop the antenna, the rectifier, make a bit of integrated module, and that integrated module can work in the real case scenario for most of the time. So this is our takeaway message. And of course, we have to simplify the funding procedure and R&D capacity. So it's something and it's good if different teams can work together, because it's not only one thing which can, for example, someone can work on antenna, someone can work on the signal routing, someone can give you a signal, the model of the channels, because we know that where are the losses. So communication, energy, RF, antenna, everything can work together to conform to a form which can give you something which is sustainable and which can go in a long-term goal. So this is the first type of the first takeaway from the lecture. The second talk was given by Professor Agarwal, and it was related to biosensing, and he gave many examples. For example, you can also try to integrate AI with the sensor modules, and focus was mainly on the biomarkers and to detect the disease, for example, at the early stage. And also we can say that, for example, can we try to personalize this for different applications. Of course, the challenge here would be, one thing is what we call sensitivity. For example, if you want to detect any disease at an early stage, can we say that even for example, he's working on this nano sensor. That means can be working one or two molecules. Now that there are two challenges: how to extract the molecule, number one, and the thing that can one or two molecule of the disease or of the cell can give the complete information. That's again is something where we have to work on. And from the hardware part, it comes to physical. He gave a good example that he's trying to develop one surface enhanced Raman spectroscopy, because the idea is that with the enhanced Raman spectroscopy, one can work even with low quantity of, for example, one or two molecules. We don't work with the normal Raman spectroscopy. The challenge here is that the cost, because if you see the Raman spectroscopy, hardware is not cheap. Of course, he was. And we should work on this. That can we make a customized dabba or module where it can go with a low-cost device, and it can work also in a real time. So there are the real, challenges, because then in this case all the nanosensors and can be work or can be make working for example cardiac monitoring, for food safety, and main thing is that we have to also find out biomarker, because one issue is here the sensitivity, or what we call false alarm rate. So can we, for example, say that if you design one sensor for a particular disease, how to ensure that that particular sensor will only work for that disease and not for other diseases. For example, like if person is having two diseases, and if you have any false alarm rate, maybe that you only find out one disease and not the other one. So there is something where you can. Okay, so what I was saying, that in this case, if you try to design this nanosensor or biomarkers, one has to ensure that under what scenario they can work. The selectivity is very good, and it can work in any kind of thing. And lab on chip. Last point is again very important part, that if you really want to make it very practical, if you really want to make it what we call very popular device, it has to be a small portable device which can be used by any person, and that will take time, because if you see the typical Raman spectroscopy, it is a very expensive device. So we have to work on this, and that's something where one our recommendation is that we should try to, for example, make different teams together so that the whole technology can be developed in-house, indigenous, and the cost of the device can come down. So that's very important thing. And so what the takeaway thing, that we can use different technologies. And yeah, so he was, for example, using one of the technique to develop what we call the electronic or current and voltage. We should also explore that can we use some other technique, like for example high frequency, like the sensor used on the RF or antennas, which can work in a non-invasive way, and maybe which can they can give you what we call the better sensitivity. Because idea is that one technology maybe doesn't fit all. So if you can have different technologies which are working in different domains, and if they all can be combined, and if they all can give you a better picture, then that should be taken into consideration, because that will give you some better idea that which technology to use for which application. Because when it comes to bio application, as was also mentioned by him, and this is a general trend, that the challenge comes when you want to detect any disease at early stage, then you don't have enough cells which are what we call the sick cells, or what even say, for example, cancer. So if you want to detect benign samples which are not yet malignant, that's a very, very challenging part, because in this case you have to have very high sensitivity, so that you can demarcate between the healthy and the benign tissues. So under these kind of scenario, it might help if we have different technologies and they can work together to find out that is it really a correct idea or sort of false alarm rate. For example, nowadays if you see you are having X-rays and ultrasound, sometimes they both give the same information, but you use to verify something really the case, or maybe it's not working in one case, but it might work in other. So that's something where you have to work on. And the real-time testing again. So idea is that if you really want to make any technology to be viable in the long term, it should be giving you data in real time. The way, for example, if you go to today if you go to X-ray, by digital X-ray you can see on the screen. Now something like this should also be shown, or should also be tested, and this should also be worked on. That can we try to work in this aspect? That is very, very important part. The last talk was again on sensors, but it was mainly focused on flexible sensors and especially for gas detection. So Professor Panda gave an idea that use usually polyaniline as the organic semiconductor, and this is again a very good aspect from the point of view of sustainable future, that can we use the organic semiconductor. It will be cheap, it will be sustainable, and also we don't have to worry about the what we call the material cost. The only thing is that can we make it workable, or can we make it overall application oriented, which can go for a particular scenario. Now for gas sensing, like he has shown many examples that yes, it can detect many of the gases, but again here one thing which comes here, the selectivity. So for example, you can detect ammonia, you can detect methane, but the point is that is it possible that if you design a sensor to detect ammonia, it will only detect ammonia, or it can also detect, falsely detect methane as ammonia. So there's something, selectivity is important, and for this again, so there are two aspects. On one thing is what is called selectivity, that you want to select only that particular thing which you want to achieve, and second thing what we call sensitivity. That means we want to say that are we able to detect even a small quantity of gas, for example, which is cannot be even sensed using a normal human nose. And there, if you recall, this was the focus, that how closely we can mimic the actual human. Well, of course, we can totally mimic, but we should try to approximate, because in that case, and what we want, for example, if we already know that there is some gas you can smell, then it's of no use. We want that it should be done at such a level that even before human can sense, and that's the challenge, and that comes what we call the sensitivity. That can we try to ensure that even such a low level gas concentration, any dangerous gas, whether ammonia or methane, can be sensed before human human nose can sense and detect. Other challenge is that, of course, sometime we want to use what we call remote monitoring. So imagine that you have a lab, you cannot be 24/7. So if you can have some kind of arrangement where you can install a device, of course, the aim was IoT and sensors. So this is a very good example that if you can try to integrate one IoT enabled sensor, then you should be able to monitor the that particular thing from a remote place, from anywhere in the world, say just by using one IP address. But then you have to what we call revolutionize, that you have to implement or integrate both the IoT component and the sensor hardware. Of course, now it's not difficult, because you have already IoT sensors not available in the market, so you can just try to integrate. But that should be done so that it can be done from a remote place, and that is something. It is the main theme also of this workshop. That can we try to combine the hardware and the software, which means the cyber systems, like IoT is one of the examples. So that is a very, very relevant part, and one should try to work for every kind of sensors. And then also what you can see in the last slide, that one is trying to design artificial nodes, but something better than this, because then we should be able to sense which is beyond the human limitation, and also from the remote place. So these two things, and remote place will come under IoT, and this thing will come under the normal security issues. And finally, that he sent something more points, like we should try to develop IoT is not being done, but we have to work on this. So, and we should look into technology from both the sides, that how much, for example, how much knowledge we have, and then can we also push for more technology, because it has like to and fro, it's not only one way affair. And though we can say how much requirement we need, competence of course should be done at every level. And as I mentioned earlier, we should try to develop ecosystem where we can develop different kind of sensors. Whether it is what we call for based on electronic, based on low frequency, high frequency, chemical sensor, electrical sensor. So all the things can be done from that perspective. And finally, if you visualize that we try to develop the sensing system for this, and we try to use the general framework of this cyber thing. So we have to combine all the efforts where AI technology can be used with this sensor form, and this only can be done if you say you want to have feature which is at the end. If anyone works together, we will envision that we can see the future as the lead mark for energy sensing, including what we call the energy sensor, that we can try to make the different form of energy which can be used for energizer power devices, and also of course overall intelligent automation. I think this is something which I can miss. Thank you very much.
My sincere request is that please restrict your comments to key points, and maybe for not more than 2 minutes to start with, so that we can have more discussions rather than presentations.
Again, very good morning to all of you, and to a very focused point with respect to the deliberations happened in the last session on the cyber-physical system for agriculture. Is how this geospatial technology can be used for the CPS, particularly for agriculture. And for that purpose, we have coined a new word called cyber agro-physical system. And quite some time now, but I don't know, if you look at Google, nothing like that is available, but we take agriculture as a physical system. So it's called CAPS, cyber agro-physical system. Under that, huge applications, you can look at all those technologies related to fish and agriculture, natural resource management, livestock, fishery, anything you want to. So this is what the physical system, this is what the sensor application. So, so in the first deliberations by Professor Roshan was on that, how these technologies can be used to bring the precision strategy from sowing to harvest even to the consumer level, and also going from simply low-cost sensors from IoT to the satellite. Coming back to the second, so this is what the acquisitions data which can be done with different sensors, multimodal sensing, data analytics. Not only that, also he has covered about the digital twin, synthetic systems, how you can generate simulations. Again, you can use generative AI and data analytics. Coming back to the second part was more on application oriented, using the
Just listen to the talk, so we not summarize it.
Oh, then it's okay.
Observations
Then
and
coming back to
recommendations.
the next point is how this, whatever the data acquisitions we have done, how best we can make it implementable with respect to bringing precision, bringing the variable rate technology. And this is what talked about Professor Rohan, Professor Bharat Lohani, and how we can go for multimodal sensing and computer vision, and go for the various input applications to reduce the input loss and also efficiency. And that's what the precision agriculture stands for, optimization of whole system. So one of the technology what he was showing is there is only one technology. Like this we have many, how we are going to come up. Coming back to the third one, again a lot of waste you are getting from agriculture, a lot of waste. You must be knowing right now the pollution started in Delhi after Deepavali. People will blame on the residue burning and most of the northwest part of the country. So he was talking of the chickpea, and we can talk of any waste coming from agriculture. If it can be used as a anti-corrosion material, or some of those gadgets or sensors which can be used for the purpose. And yesterday also I was seeing there is a drone made out of cane weeds, cane grasses, low weight and highly anti-corrosive. So by aerospace department here itself. So conclusion is the huge applications, coming back to the geospatial technology, but how best to make it a translational research to go to the penetration level. So this is what the large gap lies with. So how we can modify that with respect to adaptability, and looking at the Indian ecosystem, how we can make Indianization. Second part, how we can make it Uberizations. And of course, we need to bring a transformation with respect to the other side, the stakeholder. It's not individual farmer who can take all these technologies, rather it is the
farmer producer organization, that's what the big initiative government of India is taking, a cooperative way, contract farming way that all these technologies can be penetrated through. So there are many low-hanging fruits which we can look at, looking at those commercially available commercial crops, cash crops, and also looking at some of those industry, the crops which are more into related to industry, looking back, okay, people will be very happy to take up these technologies because huge loss happens if at all something goes wrong. So this is what the my initial points. Maybe later I can add on. Thank you, sir, so much.
Thank you. In this session, another session on cyber physical system, we had 3 talks. The first one was on energy efficiency for cyber physical system. It's very, very important because how every application we are moving for this cyber physical system. There we talk about computing memory kind of systems and devices. That is, I think, very, very important. Lots of he showed the promising result. So that is, I think, an area where we need to go further. The technology still needs to go to the field. So that is something which is required. The other one was on autonomous navigation. And there again, I think what we discussed is like from the Indian perspective context, we need a customized approach where we instead of completely autonomous assisted technologies can be and driver assisted technology can be developed. The fundamental models are developed, but still we need to focus on the accuracy in the open areas. In the controlled environment, they have already tested and it's working well, but in open areas, because of GPS accuracy, etc., there are limitations. Digital twin development is something that they mention is the next steps for the cities, and the vehicle probably will be required, and then the networking of these vehicles, the cities and the road will probably result into better outcomes. And the last talk we discussed about the application of CPS in production system, where we emphasize the importance and the need of integrating the MSMEs in the cyber physical system development, both for their own the MSMEs efficiency point of view, as well as helping large scale industries for the development of CPPS at their end for the end product. So I think these are some of the points which can be taken out. In general, I think we need to have a customized approach for Indian applications, Indian roads, Indian manufacturing environment, which will be very different from when we compare it with the Western world. I think it will be very, very different, and we need to have those kind of customized approach. This is how I summarize the 3 talks.
Yeah, so I will be talking about the session which Mr. Behra was supposed to summarize, but anyway, as the chair has given the responsibility. The first talk was by Chaudhury. He is a university here. He can tell more. He spoke about non-invasive brain stimulation for rehabilitation. He spoke about various aspects and the various methods, processes, what he has been doing the research, how to predict the cases in case you have the data. So take-home message from his to me is a thrust on this research to bring affordable tools to save lives. Next was by me. I spoke more only on IHFC at IIT Delhi. I have Foundation for Robotics. It is one of the 25 TIH Technology Innovation Hubs under NMICPS of BST. I spoke about various activities under the heading of research and development, startup, skill development, and international relationship building. So take-home message for this is bring product from lab through appropriate awareness. Now when I say appropriate awareness, I mean we faculty are very good doing research, proof of concept. Whenever it comes to commercialization, there is a big lack of understanding, so-called, the value of debt and etc. And then what to get the funding, how to go to the market, etc., etc. So in a way, how can we create a new generation of faculty and researchers for the days to come? The last one was by Professor T.S. Gandhi from IIT Bombay. He spoke about compliant mechanisms for robotics and automation. He spoke of various applications and products. One of them I remember is the micro universal testing machine. He gave the advantages of how to make jointless mechanisms or machines. So take home message for this is design focus exploring complex mechanisms first because of the advantages of energy savings and less actuators required. At the end, I want to give a general recommendation for INAE. All these presentations made, can there be proceedings out of it? And what not in a very classical way, because I don't think any speakers will give any article. Rather, all these presentation be dumped into ChatGPT kind of thing. Can it create a proceedings and that can be checked, vetted by us before it goes to printing and sharing with us. It will be a very valuable document. Thank you.
Thank you, Shubhi. I think there has to be some documentation of what we discussed and what are the recommendations were, and not only in these group as well as other group and combining together. And that should be a record of proceedings of these. I think I would just like to pose one question to the panelists. Let's see, we have seen in these presentations some sample of technologies which are being developed in the country in these areas. It is not an exhaustive set. There are lots of things which are there which have not been presented. Now the question is, since with your knowledge of what is happening and what you have seen here, what do you think should be the direction of the future development in these areas, so that it also would inspire? I see many young participants here. That may inspire young participants as well as may throw some light towards a direction in which Indian SMT should progress in these areas.
Yeah, thank you very much. So I would just try to give 2-3 points regarding the theme, what you call, and related to the sensors and technology. So first thing about the sensors. So as you know, now sensors are used everywhere. Now the question is that how can we make sensors which are compact, and I would say one more step, which can be using materials which are sustainable. So we can solve the degradable material, organic materials, flexible and wearable. I think if we use these 3 tags together, flexible, wearable electronics, printed on using very atomic technology, and then we can use these sensors for biomedical application, agricultural applications, biomedical, for example, to detect what we call the different types of disease, even to detect, for example, we are working on, many groups are working, for example, to detect alternate way of using like the cancer or using other kind of blood cells. Then agriculture, a lot of applications has shown, for example, like we big developed sensor to detect milk contamination. Amul came the other day and said, okay, we want to have some other technology because they are using this lactometer to detect milk quality, and say it's not yet now fully foolproof because farmers are able to, somehow manipulate. So we have to use alternate form, so we can use this one of the good applications. Similarly, also in India, one challenge is like the food adulteration. Can we detect, for example, like there was example was shown for honey, for milk, for all kinds of things. But it should be compact device, enabled, and then only you can go to the next device. And also it should be IoT enabled, that we can detect data from all the places. And coming to energy part, energy harvesting. So there is a way to move forward, that because if you see solar energy or even like wind energy, the cost is a factor. For example, like people say, if there is no incentive by the government, it can justify the cost. So we have to look for alternate form of technology which is economical and which can work in the long run without any subsidy from the government. I mean that's something where we have to work on it. And for this, many technologies have to merge together. For example, one thing was also shown about the RF harvesting. For example, we have to combine. For example, you have a simple material which can combine like solar, RF, piezoelectric all together. And for this kind of thing, for example, one thing is the material. If we develop nanomaterials which can try to give us more economy and also more, thing from the actual point of view. And then this is also one of the talks on nanosensors. So materials is also one of the key steps. Can we develop biomarkers or even bio materials which are sensitive to anything, and then we have to integrate. We have to integrate nanomaterials, electronics, IoT, and I think that will be a real cyber physics system from that point of view. This is something that
to be very brief, very generic way I can say is it should be more of a demand driven, not the fund driven. The technology should be. We have huge depth of technologies available all around. And demand driven means the stakeholder oriented. The stakeholder is, if at all I am talking of agriculture, the session just we finished. How all these cyber physical technologies can be used for agriculture purpose, we should see, and who are your stakeholders. So we may categorize and accordingly we should orient. One. Second is we should look at the economics. If at all it has to be adapted, what is the economics and how much the bucket allows for the stakeholder to use it for. So that way it can be categorized. Another is the scalability. At what scale, the marginal holders we are almost. So how to scale to that level to see that some of those technologies which can take in an acre field, which can be taken in a large area. So this is what the third is. Every technology has its own lifespan, like everything. So we have to be sustainable with respect to technology and translation to the field level application. And most important remains is what we see outside. Of course, nowadays we are doing that. Public-private partnership. Every technology can be put into a business model to have a deep penetration, translations, and since both the Lakshmi and Saraswati are together, I think it's going to be sustainable. Thank you very much.
Thank you. I would probably bring another angle here, again, a specific thing. To all the researchers, young students, I suggest if you want to really make an impact with the cyber physical system, please visit the end users. That's something we miss. We keep on developing things which are, yes, important, but the application poses a very different challenge. I'll give you a couple of examples. Many times we see infections happening in ICUs. It's very important aspect. Many times doctors tell that no, we could not do anything, patient died. Surgery went well, but that some infection occurred and so on. Many times this infection occurs because of the non-compliance of the procedures. Nurses sometimes don't clean their hand with the sanitizer, etc. Now, when we discuss with many aims, the simple problem can we put a camera and monitor that, whether the compliance is there. It can reduce the infection, and also it can help in antimicrobial resistance kind of problem. So these things will come from the field only. One day, one doctor mentioned from AIMS, I can tell you, that what happened is the ICUs, the ventilator screen got stuck, software problem, and the nurses could not see the variation, the parameter. They were happy the way patient is behaving, but it got stuck. You need a simple camera to monitor if something is not changing, and what happened to the patient. You can imagine his condition got really bad, and something happened. So these kind of things are very important when you go to the field. When you go to the Prathmik Swasthya Kendra, you will find that every ASHA worker is writing the simple information in very different ways. It's not just the language, even they write the numbers, they date, for example 10/12 or 10/12 25, something like this they write, and then if you want to apply a simple OCR based technology, it becomes a challenge. So need to develop customized solution for India specific thing. Another thing is India specific knowledge, that the ancient knowledge. Many doctors, in fact, from various hospitals are now thinking in that direction. For example, earlier days, the so-called web used to just see your tongue and diagnose many things. Can we not take picture of that? Now we have good image processing technology, and can we collect such kind of data and give more sense to our ancient knowledge? Try to think, take certain riskier project, not the conventional approach. I think another important area. So I'm just giving sample, but you will understand that there are many things which we are not still touching. For example, the heart rate just before the birth and after the birth, if you can measure. Also, you can link it with the analysis of the cry of the baby, which used to happen informally earlier days. But now you have all the tools available, technology available. Can we take those those data, collect those data, analyze? Then one of the very senior neurologists mentioned that it impacts the cognitive development of the child. But we don't have those analysis available. So when you go to the field, you will find many such important problems, some strong evidence that we need to prove with probably your scientific, all this CPS based research. So that's what my take for the student. Please look into the applications, go to the field.
Okay, so from my side there are two basic points. One is don't look at the product level only, because we as engineers try to resolve problems. Look at the system level. What do I mean? I will illustrate with an example, which is through my UTAC experiences. There, like we have developed some improvement in a device which is used by the artisans of Tulsi Mala beads, which are used as the garlands for the devotees of ISKCON, right? So when we looked at the product only, then after the product has been made and given it to the village, now who is going to repair it? If the DC motor, we used it and the DC motor has gone bad, the brasses have been deteriorating, why from get the brasses, so it has to get from Delhi and the people are not using it for next 3 months, right? This is one. Then after it has been made, then there is a certain demand of 200 pieces, right? Who will make it, right? And so the point, there is a PhD thesis done in last 5-6 years that okay, look at from the very beginning, who are the users, who are the manufacturers, who are the maintainers, entrepreneur. Finally the business, like it costs about 18,000 rupees and they are not affording that amount. So what is the new business model? So we have used what is called the product service system concept. So in nutshell, look at the system level, not the product level. The second part, we are doing CPS, as the first panelist has said, that how to, second panelist also said, then how to get the India-centric things, right? So in this case, this Tulsi Mala thing is India-centric, but we have been exposed to all this so-called sophisticated knowledge. Can they be implemented? The answer is yes. So after doing all sort synthesis of this Tulsi Mala, finally we bumped down to, we implemented a robotics technology, BLDC motors and the VFD, right? That has increased the cost, and then when you realize the cost cannot be reduced further for the quality of this product, then we go to the new business model, right? The second part is there are enough number of applications available. In fact, I am thinking of to implement IoT in this device of Tulsi Mala, so that how many hours this thing is not being utilized, how many bits are forming. I just have to put a small SIM card there, and that's it, the data will be collected at my data. So these are the two things I suggest, how to utilize CPS knowledge for our so-called rural or our grassroots problem. And the first one is basically look at the system level, not only product level. Thank you.
let me just summarize. Now, broadly, what we have found is that there is a huge opportunity of using these different aspects of cyber-physical system to touch life of human being. I think which is very, very important. See, technology is not just for abstract demonstration of know-how or sophistication of technology, sophistication of knowledge. But what is important is that at the end of the day, technology should reach people, should improve their life. I think from that context, I think what has been placed and what has been stated, say for example, if you look at from energy harvesting, which actually is critically important for sustainability, to the sensors for point of care healthcare, which is actually referred to the kind of problem that was being referred earlier, to actually people-centric automation in agriculture. These are very, very critical for the Indian context. And more such examples has been given by both of the panelists in terms of how do you address the problems which are coming from the field itself. And many a times we ignore information. Today we have the ability to capture a variety of informations and we have the ability to get that insight. I think that is also important. So for example, we may ignore some observation as trivial, but those observations, actually what Lad was talking about is that cry of a newborn just before birth and just after birth, that itself can have information. We always know that happens, but have we tried analyzing it? So these are the questions. This is what is called a kind of inquisitive approach for innovation. That these questions really lead to innovations, and that's also part of the scientific culture, which actually can help all these things to grow. And what finally should be talked about is that a simple thing which may be looked at from a rural development or rural need point of view, but that does not mean it would not require the most sophisticated technology. In fact, that's what also seen in the case of leader-based these spray of insecticides in a very targeted way. So for all this context, I think the problems which are at the grassroots, they're the most challenging problems. So it's better to look for those problems than look at papers for solving the problem. This is particularly for the younger people who are looking for problems and they move forward. Thank you. I think it was a very entertaining and informative and exciting session for all of us. Thank you.